This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hey, I'm Lee Bortons, and it's Wednesday, September 4th, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families enrolled in classical conversations communities. Our club is preparing for our first semester by going through each lesson each week so that we can help our students to know God and make Him known through mathematics. And I hope that you're enjoying these highlights on strategies that Kirsty's sharing with you, and as well as each other, for leading your children through the math map. So Kirsty, thanks for being here. And what do we have today?
Well, we are looking at division today. I think that's everybody's favorite operation. We all love that. Probably a lot of you have heard that I lost more than one recess because I did not like doing division. And so, yes, that's where we are today. But before we start, I hope you'll indulge me because I just thought I'd share a little story from last night. So we had to go up to the big city to pick up my car from having been fixed, and afterwards decided that we'd like to stop for an ice cream. And so we just picked a place at random and we walked in and we were just baffled by the menu board. We could understand maybe about 10% of the offerings, and fortunately that was where the ice cream was. So we were able to find something that we wanted to eat, but the rest of the board was really pretty foreign to us. Things like dewy matcha latte with creme brulee cap. And I had no idea what that was. And there was no explanation. There was not like, hey, this is what this means. There was nobody who said, can I explain it to you? And so we left not intrigued, not wanting to go back because we kind of felt excluded from their menu because we just didn't know what any of these things were. And there was a lot more. That just happens to be one of the examples I remember. And it made me think about math, right? That so many people feel excluded from the conversation because there's words and symbols that we don't understand. And so there's this maybe a little bit that we do. And so we focus on that. And the rest of it, we just go, I don't know. Had somebody decoded that menu for me, I might have gone, okay, I don't know what that tastes like. And I don't want to try it today, but I might come back because maybe I'm intrigued enough to come back and try it next time. And so as parents, I think our most important job is to be that decoder, right? Our students may not try everything. They may not taste everything, but maybe we can decode it enough so that they go, oh, that's what that symbol means. I don't care about it today, but I might come back and try it next time. And that's how we're going to hope to invite them into that conversation. And I know for some of you, you might be going like, I've been excluded too. And so you're going to have to put some of that work in order to bring your children along. But I just wanted to encourage you because for me, I think I felt like maybe how some of you feel when you look at math. And that's not what we want you to feel. We want you to feel like there's somebody there that's going to help you decode it and invite you to come back and taste and try different things. All right, so every week we start with our math map and look at where we are. So just a reminder that you're going to look whatever domain you're using at home, choose that column. We are on lesson 6, so we are on this row here. I'm using the complex, and so as you can see, we've got a check mark there. These check marks are going to be going away, and you're going to have a blank page here soon. So hopefully you're picking up the pattern. And we're going to go ahead on into our number knockout time. So I'm going to go ahead and click start, and you guys can go ahead and start calculating.
6 plus 3 plus 2 is 11.
6 plus 3 minus 2 is 9. No, 7.
6 times 3
6 to the 0 plus 3 to the 0 plus 2 to the 0 is 3.
6 times 3 is 18 minus 2 is 16.
6 times 3 is 18 plus 2 is 20.
Mhm. 6 times 3 is 18 times 2 is 36.
6,
Yeah.
and then 6 times 6 is 36. Or 6 plus 6 is 12.
6 times 3 to the 0 times 2 to the 0 is 6.
6 minus 3 minus 2 is 1.
6 times
3
2
times
is
2 is
12
6 times
plus
6
3 is 15.
Yeah.
6
Maybe-
times
wait,
3 to the
6
0
6, 12,
minus 2 to the
15,
0 is
18
5.
divided by 2.
Is
3 plus 2 is 5, times 6 is 30.
6
18
times 3 to
divided by
the
2 is
0
5.
minus
Yeah.
2 is 4.
I think if you did
6 squared is
squared.
36, minus 3 squared is 9, is 25, minus 2 squared is 21.
I did 6 squared minus 3 is 33.
Couldn't you
Times
do 2
2 to the
because
0
you
is
do
33. Nope, we just got
6 to the 0 power and then 3 to the 0
6
power.
times 3 to the 0 minus 2 squared is 2.
So you're saying 6 to the 0 power, 3 to the 0 power, plus 2. Oh, they already got it. Yeah. Is 2.
6 squared is 36 minus 3 is 33 plus 2 is 35.
So 6 squared minus 3 is 33, minus 2 is 31.
All right. Good job, everybody. Let's go ahead and look at our cover. And so our cover today is a piece of a bigger piece of art. And it is the separation of light from darkness by Michelangelo. And one of the things I want to invite you to think about is we talk about separation here. What are other words for division that we may know?
Splitting. We split the bill, we divide it.
Okay, good.
Break apart.
Good.
Is fractionate a word? It feels like it should be a word.
Fast subtraction.
Group.
That's a good one. Like we don't really think of grouping a lot of times as division, do we?
How about fractional scaling?
I think of distribution as multiplication, but it can also be division if you're distributing something among several people.
Like that.
Opposite of
roots?
multiplication.
Okay, good.
I like Tanya because we make up words too, and sometimes I call it undistributing.
Good. So I think it might help our students to sometimes realize that we have all these different words, especially for division. We have all these different words that are describing a similar process. Right. And so it's not just the idea of long division, my personal nemesis, right? But it's this idea of anytime we're splitting things up, right, that we're dividing and separating.
So with that definition, then you want words like percent and ratio and decimals.
Those are excellent. Yep. Let's go ahead and look at the art. And what do you think about the art, and how might that change how you think about division?
It looks like the man is the divisor. He's the one that's causing the division to occur.
When you
When I think about division of light and darkness, there's a haziness in between. It's not that it's daytime and then sunset happens unless you're in a mountain and then it's all of a sudden dark. There's a gradualness to it, which I think can lend to remainders and stuff like that. I don't know.
And I think sometimes, you said division in the opening there is something that's divisive between people, but it also can bring clarity that what is light and what is dark. And even though darkness, only definition that's scientifically accurate is the lack of light, it's not its own thing. It still helps us to think of the division between whether it's good or bad or dark or light, or just, Oreo cookies.
Emily
What
said
light
painting
and
looks
darkness
cracked.
is he talking about here?
Is this the firmament, Michelangelo depicting God in the 7 days of creation? So that's one thing for some folks, because it's such a blown up piece of that, much, much bigger piece, it might be hard to distinguish at first. There we go, we divided. We took it out.
So
For our
Emily said
days,
the painting looks cracked. It's divided. However, it's all part of the whole picture. I
like
like
that.
that.
So how about this? How about when we think about our days, right? Just think about today. Is today evenly divided, right? So here's another idea, right? This idea of evenly divided between light and dark.
Yes, I feel it to my very core. I just came back from Taiwan, so I'm 12-hour jet lagged.
I was thinking about the divisions between the clouds and how they look like they're even subdivided even more and into many different increments that aren't necessarily even.
Mhm.
Yeah, when we divide mathematically, do we like it to be even?
It's easier.
Yeah.
And that just shows our love for natural numbers and wanting things in natural counting numbers, and why studying broken numbers just pretty tricky.
We had a conversation yesterday in challenge 3 about math in motion. Like, we're trying to figure out the difference between simple meter and compound meter. And I had put 6 quarter notes on a staff, and well, and actually 8th notes, but I had barred them I had divided them into 3 groups of 2. And then suddenly we had this epiphany that would have to be 3/4 times simple meter. But if we barred them as 2 groups of 3, it would have to be 6/8. And I know you may not understand what I'm saying, but all of a sudden, like, all these light bulbs came on in the classroom. It was like, that's why it matters how you divide it. That's why the meter, like, it was one of the coolest challenge moments I've had in a long time.
That's great.
This isn't exactly mathematical, I guess, but there's just so much movement in the image, and so division does bring movement as well, just moving items, grouping items, separating items. So I don't know, I just, with the swirling light and everything, I like that part of it that I wouldn't normally think of with division.
It's a good reminder, Karen, that sometimes our students, even right, if we think about our Challenge A students, they feel like they're part of the big kids on campus now. But even for them, if they're struggling with division, sometimes having that tactile experience of using some kind of a manipulative to have a group and then divide it, right? Or even just with marks on paper, right? We talk about like part whole circles and being able to take something and say, I'm going to literally put something in each of my groups to help them visualize division, because it's an undoing that makes it harder. All right, great job on our conversation today. Let's go ahead and move on to our I-squared page. So as we look at this page, there's 2 big ideas on this page, right? Our week is division, but we'll also have a lot of information on here about relations and functions. So if you are new to the math map or new to working through right, these ideas, maybe you're reclaiming your own math education, think about all the things you already know about division. And we talked about some of them there, but you can bring more in. If this is your second tour or your third tour through the math map, and so you've seen functions and relations, tell us some things that you know about functions and relations.
So you're asking two questions. If you're new to this, look at the top basically, or other things that catch your eye. And if it's a second or third time through, give us something deeper.
Yes.
Well, number lines show the relationship between different numbers. And we cannot have that relationship in zero dimension. We're just left stuck in one place.
Good.
I really appreciated when Kirsty taught me how the hops align with the vectors, because as an engineer, I use vectors all the time, and I realized I never once understood them. And so now I'm excited because I understand them, because they're just like hops with a few extra properties.
So this week in community, we did week 3. And so this top number line looks very similar. And so I like that we're still seeing the same type of number line. We're just seeing the information presented in a little different way.
For functions, it reminds me of the common topic of cause and effect in relationship there. And what is the effect of applying something to an equation and then you get a result?
We're seeing, I love that a couple of people have sort of referred to the connection there between a mathematical relation and our common topic of relationship, right? That relation gives us that sort of cause and effect, that relationship between two sets. And that's what, when we think about the common topic of relationship, right? That idea of cause and effect or order.
I'm not quite sure how to ask this, but is a relation, relation isn't a genus and function is a species of that, is it? It's there in this context, if you say relation, you're inferring that it's not a function. Is that right?
No, you were correct that the relation is the genus and function is the species, or that functions are a subset of relations. So a relation is just any mapping between two sets. And I can have one to many, many to one, many to many. I can kind of set up things in different ways. A function is a specific relation. And we're going to look at that in more detail, especially in 2D. We're going to come back and look at this in more detail. So this is a really great example of where we've brought ideas from multiple dimensions together onto one page. And that's why I said, for your first time through, some of this may seem really foreign and you may not know much about relations or functions. And so you may just focus on the ideas of division that are here. But if you've been through the math map, you've seen relations and functions many, many times. And now you may be able to step back and go, okay, well, I understand that functions are a subset of relations. And the big idea is that a function is that every x has one y. There's just one y for every x, right? So if I give you an x, you know exactly where that's going. But in a relation, I might have two y's for an x. So think things like circles or sideways parabolas or sideways absolute values, right? So those are relations. So our functions are also relations, but when we want to talk about things like circles and parabolas on their side or hyperbolas, that's where we're going to use that term relation as a more general term.
Kirsty, should I go back and take those three boxes in the middle and say relation that's a function, relation that's not a function, no relation?
You could do that.
I think would be clear.
All right, let's go ahead and look at our Memoria page today. There's a lot on here. Tell me what is familiar to you from this page. What have you seen before?
Laws, commutative, associative, distributive identity. I also know inverse property of zero.
We even saw some of these last week in our booklet.
So we've seen those names of the laws. We saw them in the addition week, the subtraction week, the multiplication week. And so now what are we adding to this list?
Vision.
Expressing them for division, right? What do we notice about addition and subtraction? Does everything work for both addition and subtraction?
No distribution
Good.
or no
Not
distribution.
commutative.
Not commutative. Good. How about multiplication and division? Do we see that same pattern where it works for one and not the other? Yep.
Yeah.
So this is another good example of where we've taken information from multiple weeks and we brought it together into context. And so we see these laws that we're practicing every week, and then we're seeing how they might be expressed with different different ideas, right? With different operations. So what might be some of the things that we could memorize that you might choose to have be the first thing that you memorize on this table?
I would start with where it doesn't work, like the commutative and associative doesn't work with subtraction and division. Because they already should know, if they've been through foundations, they know it does work for addition and multiplication, but to add it doesn't work. And then same with the distributive, that doesn't work for addition and subtraction. And then learning the identity for the ones you didn't learn in foundations.
I love that you went there because that's what I do too, Donna, to look at what's the simplest amount of things I have to learn. And there's only 5 exceptions on the page, 3 with not equal signs and the one that's 2 boxes with there's no distribution. Because I can remember 5 things faster than I can memorize 4 times 13 things. So that's
It's
just
also
good
you're
pedagogy.
building on what they already know. They
Mhm.
already know some of these things. So to add one more, say easy plus 1.
Mhm.
When you compare it to the multiplication, as you're memorizing 2, it almost seems like you're getting 2 for the price of 1 because you're just kind of getting an opposite in some of those laws.
Good. So that's great. So there's a great strategy, right? To look at multiplication and division together, to look at addition and subtraction together. Good.
Can you refresh my memory? How do you say the arrow, like for the symmetry, for example, a plus b equals c, and then that arrow, is it follows that or
Implies, I usually would say implies. The double arrow that the double arrow, that's an implies. So a minus b equals c implies that c equals a minus b. It's a mathematical shorthand for if then.
Yeah, okay.
Now, for some of our students, looking at all of these letters may feel overwhelming, right? But so what's something, if you were helping your student to remember the idea, maybe not necessarily the form, but the idea, what could you do instead of using letters?
Put in numbers.
Put in
1 and
numbers,
2.
right?
Or,
There you go.
or objects,
Or objects, good.
I can move around. Yeah.
Numbers no more than 10. It's like single digit.
Digits.
There you go. Yeah, right. It doesn't have to be hard, but helping our students to say, like, they might go, I don't know what you mean by a plus b equals b plus a. But if you said, well, how about 3 plus 4? Is that the same as 4 plus 3? Well, yeah, stupid. That's, they know that. So that may be a concrete way to move them towards the abstract. Notice that if you did that, if you blanked this out and just put some numbers in, you're taking this from being a Memoria page to practice calculation page, right? So there's a lot of ways that you could take these resources. If you're like, well, we just need some more practice on these laws, just throw some numbers in. And I also think that that's a great skill to give our students. When I was a classroom teacher, that's what I used to try to get my students to see is if you don't know something, if you're struggling to understand something, replace the letters with numbers and see what patterns you notice. So helping our students to recognize, I can just put numbers in place of those letters and it's going to take me back a step and make it concrete where maybe I don't see the abstract, is a strategy for learning that may help them.
I
The
was
other thing is with your children is take into account their ability. At home, it might be your younger ones, you don't even talk about more than the first 3 or 4 rows, but an older child maybe does 1 or 2 columns. And then of course, your, challenge 3-4 student, you might say, no, make up numbers and go check that you know how to do all these and do the whole page for me.
And for a smaller, a younger child or somebody who's feeling overwhelmed with all the letters on this page, I've never thought of this before, but I think I'm going to get a couple pieces of construction paper or something and cover up like parts of the chart so that he's just looking at one line at a time when we're going through it. I think that might help my son a lot.
And I was thinking, Kirsty, like you could do the simple numbers and then make it really fun. Like, okay, give me a gigantic mega number, bazillion plus bazillion and just show them that it works the same. It's just the same. And I think that always makes it really fun. Like, give me a gigantic, huge number and kind of play with it a little, make it fun, make it playful.
That's a great idea, Anne. Good ideas, everybody.
That's
And
Amy.
oh, sorry, Amy. I do that every week, don't I? I don't know why. Like one time you get somebody's name wrong and then that's it forever.
Yeah.
Jana, you reminded me that we've heard right. So that idea of covering up pieces of your Memoria page, you can cover up parts of your chart. On the flashcards, people are covering up the answers so that their students can focus on just the top part, right? And so reducing what your student is trying to see visually is a great strategy and a really easy way to tailor this for your student, right? Even in covering up parts of the lesson page and being like, no, just focus on this piece here may help students. All right, that moves us along to looking at our charts. So let's see what we can find that's familiar or unfamiliar on our charts.
Before we do that, I want to say that all the things you just said really would help with the charts too. And another thing is, these charts really were designed for adults to challenge 4 students and older. Doesn't mean you can't use them if you're younger. But another thing you can do to help younger ones who are able to read it, but maybe get overwhelmed, is have them write part of the page on the board in big letters, because they tend to manage those ideas if the graphics are larger.
And I think I had a student in class this year who pulled out, and I think Amber mentioned it too, is making flashcards with the snippets that you want. So the student made their own flashcards. So like the parent was like, I want you to make a flashcard with this. So that way they would study that. But that way the parent kept the chart and the kid just focused on what was on the flashcard.
Something else that you've been pointing out, and I just want to reiterate it, is on the right side on the 6-2. This is beginning to look very familiar, and it's because 6-3, chart 3, 4, 5, and 6 all have the same layout, so you can compare the same kind of domains across the other domains and the various operations. So it would be a good exercise just to take 3 through 6 is page 2 and lay them out next to each other on a table and do a comparison. Because I want to say one thing that I find very encouraging, but maybe not for everybody else, is that all of your ideas are to help us to see the unseen, to look at what's in front of us so it can become familiar. Very few things that we've talked about so far have had anything to do with calculations, but they've all had to do with understanding the language and the patterns and the big ideas of math. And so when parents get frustrated because they're like, they want calculations, well, we got the flashcards. Other ones are like, but I want to know the concept. Well, then you have these charts that there's something for everybody. You just have to know how to use the book rather than let the book use you. And that's what I think the Math Map Book Club, yeah, you guys have been great helping Kirsty and I get that message across.
All right, 1 minute. Let's see how many people. I want everybody, and you can talk over each other, put it in the chat log, but I want everybody to find at least one thing that is familiar on the charts.
Radix point.
Long division.
The laws.
Division, the laws,
The law.
vision,
Right.
fraction bars,
Divisor, quotient,
decimal,
and
dividend,
notations,
property of zero,
hidden
Terms
zero,
for the
least common
definitions
the
of
denominator.
domains, all of that.
NZQRCA.
division.
Radicals.
fraction.
Good. So everybody found at least one thing that was familiar, right? And so remember, when we have something that's familiar, that gives us something to build on, right? To build our knowledge on. So good. All right, let's go ahead and moving on. Are there questions from your work in multiplication last week? Just pointing out, we did not ask anybody to multiply in a base other than 10. So I know that there's been a lot of consternation about understanding bases, but I just wanted to point out we're not calculating in different bases, right? And so I'm so glad to see all the wrestling that's been happening with that. But just going back and reiterating, right? That's so we understand the numbers we're working with. Our older students, maybe we'll challenge them to work in adding and subtracting and multiplying and dividing in different bases, but we're not doing that this year, right? So we're just using familiar numbers.
I would love it if Babs would take a moment to tell us what did she learn from leading us last week?
What did I learn
Yeah.
from leading?
Yeah, so we do a better job, Kirsty and I.
Ugh. I mean, I was nervous, so I was trying to learn some coping mechanisms of how to lead that many people. But everybody was so like, I don't know, like everybody was engaged, and it was really fun to just listen to everybody share. And I don't know.
Babs, I think you
like
just said something so valuable there. You just admitted that you were nervous about presenting in front of a group, right? So I know not everybody on here is a challenge director, but how many of you have anxiety or nervousness about leading the logic strand?
Yes. Every week.
Right? And so, right, Babs is like, I was nervous, but I did it. She just went back to her classical skills and her just amazingness. Right. But you are all equally as amazing, right? God's gifted all of you. And so, yeah, you all can do this. Just use your classical skills.
I have a question, and it's been in a few of our booklets now, and so I probably should have asked earlier. I've just been trying to figure it out. So like on page 1 in that top box, where it says sketch the scalar, hops, plot the product, begin at the origin. On the right-hand side of that box where we were supposed to label the domain for the line and the labels, I'm not always clear on what I'm doing with that.
Yeah.
Like, what is the difference between the line and the labels?
Sure. This is something that we can address, and it's a good reminder that our students sometimes are just going to keep going through until they have the brain space to say, I've seen this 10 times and I don't really know what it means. Can you explain it? Because we all do that, right? How many times have we all read the Bible and we read something and it's not till the 10th reading where we go, what does that even mean? So when I have a line, right, are there any gaps in that line?
No.
No. So I'm including every single point, right? And even if I was to stretch that out, right? And in our modern technology, I think we have this way of visualizing zooming that we didn't when we were maybe students, right? But if I zoom in and I zoom in and I zoom in, does the line ever look different?
No.
No. Do I ever get to a place where I see a number and nothing in between?
No.
No, right? There's always another number. I mean, and the amazing thing is that like if I took 0 and 1 and we said what's halfway in between, you'd be all be like a half, right? And a half is a fourth, that we can always find a rational number between two other rational numbers, right? Just halfway. It's going to be a rational number. Here's the mind-blowing thing, right? Is that we can always keep finding, right, that closer and closer and closer rational number. But between any two rational numbers, there's an like infinite number of irrational numbers.
Okay.
That stretches my brain. Okay. So there is not a dot on that line that doesn't have a number attached to it. And so it's continuous and it includes all the real numbers. So it's our real number line because every single real number is attached to a point. None of them are missing. When I look at my labels, okay, are there gaps between my labels?
No.
Well, but just the numbers, the labels are just those numbers. Are there gaps between them? Do I have every number written out?
Oh, not every number.
Not every number, right?
Like one half's missing and 1.7996 is missing.
Okay. Okay.
Right. So there's gaps, right? Of our real numbers, right? So there's none of the irrational numbers are there. None of the rational numbers are there. We just have what kind of numbers are all that we have?
The natural numbers.
Integers.
Right. So these are my naturals and I'm adding this one in. So it's my integers.
Because it includes the negative. Is that why it's an integer as well? Okay.
Yes. And so my labels, right, are discrete, meaning I can identify each one, not all of them are included. So they're discrete. And so now I can say, oh, my labels are made up of integers. And it doesn't even have to be all of the integers, right? So let's say I change this from integers and I said, this is negative 1/3, 0/3, 1/3, 2/3. Now what kind of numbers am I using as my labels?
Fractions.
Fractions, right? Which are part of my rational numbers.
Okay.
So that's all.
Does that help?
Kirsty, and would it be fair to say, because I think this is true, but I should know that there's only two kinds of number lines. They're real and imaginary in the math, but they're every domain and even parts of domains could be the labels.
Yes.
Okay, that helps. Thank you.
All right. Great. Any other questions from lesson 5 or our previous lessons? All right. We'll keep your questions coming, right? Because guess what? You're probably not the only one who has the question, right? You might just be the one that's brave enough to answer it or ask it. So, all right, let's go ahead and take a look at a couple of our pages from our lesson pages. Again, we are in division. So the first thing that we're going to do here is our top left box, and we're told to discuss and then complete. So when we discuss things, let's go ahead and read it. And it says that notations such as percents, ratios, oboli, and fractions are used to express the same value in rational forms. So let's take a minute to discuss that. Which of those notations are familiar? Which of those notations are maybe unfamiliar to you?
Well, I was just going to say, is oboli the mathematical term for division?
It is the mathematical term for the division sign that has a bar with 2 dots.
Oh, okay.
The plural of that, right?
It is the plural, yes.
Obelus
It's the plural. Obelus is the actual name, and then oboli is the plural, yes.
And MathMap will always use those mathematical terms. So wouldn't necessarily say to the students, oh, this is division. It means division, right? Okay. That I didn't know, so that was unfamiliar.
Yeah. Most of us are familiar with the shape, but have no idea it had a name.
Correct. Well, I always thought the name was just division. I didn't realize there was a
So the
proper name for it.
operation is division. It's just that symbol, right? It's just this, so that, remember,
Oh,
right?
ding,
So
ding,
it's
ding.
our notations that we're talking about, right? So these are all different notations that are going to express division, right? So one operation, multiple notations. And we wonder why division is hard, right? Because look at all of these different ways that we can express division. And
What
so
about
then
the
we're
box or the little house, you know, for long
division
division,
house.
you know.
Yes. I think I saw somewhere that it actually somebody that gave it a name, but I've always called it the division house, and that seems to be a very common thing. Now, I will point out that this piece here that won't circle, I don't know why my drawing pad doesn't like, but hopefully you can see the dancing. No, there you go. This right here, this bar, and so also this bar here, right? Any horizontal bar
Vinculum.
is called a vinculum, and it is a grouping symbol, right? So if you didn't know that, that vinculum is a grouping symbol. Oh, now my circles showed up. It is a grouping symbol, and so right when if I had something like 3x squared plus 1, right, I'm grouping that as one expression underneath that vinculum. The same thing, right? It's when if I think of, if I had 4.321 repeating, I'm grouping that 321 as the part that repeats. Right. So
Vinculum means chain. So it's like chaining it together, right? Like
there you go. I
binding
like
it.
that. I do want to just address a question I saw in the chat, because we were kind of here when we talk about rational numbers, that the Q stands for quotient. That's why they used Q. So you're correct that R stands for real. So we needed a different letter, and they chose Q because it stands for quotient, because our rational numbers express a quotient, right? And so notice all of these percents are telling us to do division, and they're all expressing quotients of numbers. So 200%, right, is the quotient, right, is telling us the number as 200 divided by 100. 2 to 1, right, we can rewrite that as 2 divided by 1 or 2 over 1, right? Those are all quotients that are equivalent to 2. So now let's look at that, and 600%, 6 to 1, 6 divided by 1, and 6 over 1. They're all equivalent forms of what number?
6.
6. All right, let's look below that, and it says to sketch the hops, plot the quotient, and it tells us to begin at the dividend. And so the first thing we're going to do is we're going to start at our dividend, and we're dividing it into 3 hops. So there's 1, 2, 3, and my quotient is 4, which is when it says plot the quotient, really that's just the length here. That's the length of my interval. So we want our students to see that. 12 divided by 4, right? So if I take 12 now and I break it into 4 groups, I have 1, 2, 3, 4, and each group is 3. And we just talked about the fact that these are all real number lines. And what kinds of numbers am I using for labels on both of these?
Quotients.
So remember, the labels are just the numbers underneath.
Natural
So
number.
Is it natural?
they're my naturals, right? In both cases. Now let's go ahead and take a look at this, but let's look at this in terms of the imaginary numbers, right? And so notice now, instead of having 12 divided by 3, I have 12i divided by 3. I'm just going to show you over here on the side that if I looked at this as 12i divided by 3, using my rules of fractions, I could say that this is the same thing as 12 divided by 3 times I. And so what 12 divided by 3, we already know that's 4 times I. And so or sorry, 12 divided by 4, right? We know is 3, so that's going to be 3i. And so as I take my 12 and I divide it into 3 groups, 1, 2, 3, I have each one of these is worth 4i. And if I start at 12 and I'm breaking it into 4 groups, each of my groups has 3i in it. And so my number line is the imaginary number line. My coefficients are all natural numbers. Okay. So let's go ahead and look at page 2. And on our left hand side,
let me jump in there, Chris. If you also want to understand just think of it as like hot dogs or baseballs. It's just 12 of something divided by 3. And it's just helping. And so instead of doing, fire trucks or things that are more common to the children, we're helping them to read the actual notations they'll use as they get older.
all right. So looking at page 2 on the left-hand side, we're asked to plot. And so first we have some division. So just like Lee was just saying when we talked about that 12i, and what do we do with the I? It's the same thing here with yards, right? So I don't need to worry about dividing yard by 3. I only need to divide the 2,400 by 3. Okay. So 2,400 divided by 3 is 800. So I'm going to have 800 yards. 4,800 divided by 2 is 2,400 feet. And then I can plot that. So I have 800 yards here and 2,400 feet here. And we can see that they're equivalent on our ruler. Below that, we're writing in standard notation. And so your students may recognize that 10 to the negative 3 is the same thing as 1 over 1,000. And if they do, right, you can help them see that it's going to be the same. Otherwise, when I'm dividing by 1,000, I'm going to, again, move my decimal place left, and I'm going to end up with 0.0011 or 11 10,000ths. Oh, sorry. Let me make sure I've got that right. 11, yes, 11 10,000 centimeters. On our top right, we're asked to solve. So first, let's read. Suppose the longest sandwich made in the United States was 80 yards long. How many 1/2 foot long sandwiches does that equal? Convert the length from yards to feet to calculate, right? So what does our green box mean again?
It equals 1.
Divided.
It equals 1, right? So that's giving us our conversion factor that 3 feet divided by 1 yard equals 1. So as I look at that, I see that my units are going to cancel, leaving me with 803 times 3 feet. That 80 times 3, I'm sorry, 803 times 3. Right? So your students may or may not do that in their head, or you can make that side work, right? 9, 0. So that's 2,409 feet. Or you may have noticed that our problem continued below. And so then I have 2 feet in 1 foot. And so now if I simplify this, my feet are going to cancel. I can multiply this and I end up with 4,819 half-foot sandwiches.
18.
18, yes.
It's okay. And once again, notice the answers are very often on the page. So when the children are unfamiliar with something, tell them, look around and see if you get a clue, either in the next, oftentimes in the next step.
Right. And down on our bottom right, notice we keep practicing graphing are inequalities. So this is one-dimensional graphing. If you're not familiar with that, right, this is an algebra skill, and we're not really treating it, right, they're not doing any algebraic calculations here or algebraic computations here, but it's an algebra skill of being able to graph in one dimension versus a lot of the times we think of 2D graphs, right, that we're more familiar with. But this is just graphing in one dimension. This is graphing with a single variable. And so we're graphing what are the possible values. So notice here, we're going to practice this idea of A is not greater than or equal to. Well, if something's not greater than or equal to, it has to be less than. Notice it's not less than or equal to, so it is exclusive. So we can remember that exclusive, it's excluded from the solution. It means it cannot equal, so we use an open circle. So 20e divided by 2 is 10e. So I'm going to use an open circle less than. My arrow is going to point to the left. Again, this is a real number line, but this time, notice I'm using real numbers. E is a real number, Euler's number. So these are actually real labels. I didn't have to calculate with E. I didn't have to simplify it, but it's still a real number. Looking at our bottom one, B is less than, B is not less than or equal to means B must be greater than. 4 divided by 2 is 2. Again, it's exclusive, so it's an open circle at 2, arrow to the right. All right, so.
Can I ask a question quickly?
Yeah.
Christy, is the reason that you exclude the equal sign part because you said it's not, so it's not greater than, and it's not equal to as well, so it can't be included? Is that right?
That's correct.
Okay.
Yeah, had that been A is not greater than, right, then it would have been A is less than or equal to, right? So we have to figure out paying attention where that goes. And that's a skill for our students, right? Just thinking through, if it's not greater than or equal to, right? Oh, that's less than. What if it's not greater than, it's less than or equal to, and so forth. All right. So let's go ahead and look at our resource reminders. I'm going to click through these quickly here because I want to give time for questions today. But just remember, every week we're going to look at these and remember we have so many resources to dive into. We don't have to use all of them. Some weeks we may use some more than others. But using our resources is one way to help us to be successful in becoming familiar and more fluent in the language of mathematics. And here's some more of those support resources for you. And next week we'll be on lesson 7. And then September 25th, we're going to dive into 2D. So be excited for that. And now it's time for your questions. So what questions do you guys have that you would like to talk, or things you'd like to share? Maybe you guys have had a success this week and you'd like to share that. So this is your time.
Can I share something really quickly?
Please.
I just had a mom text me as we were on this call, and she said, the more I click around the math map and just explore all the things they've come out with so far, the more it's just making so much sense. I wish I had taken the time last spring to just sit at the computer and explore all of it rather than the pieces. I just know the more I look at it and understand how it's built, it's going to click so well. That's my hope, haha. And I thought this was really beautiful as I was having all of these aha moments today as well when we were looking at the other pages. And like with the Vinculum, I saw the Latin connection as well that people were talking about in the chat. And then also the crossover between our reasoning strand and challenge B1 and 2 with some of the math that was on those pages. So I just want to say that when we take the time to actually look at it, we can truly see the beauty that is in it. So I'm hoping that everyone can continue to encourage families in that way.
Thank you so much. It's very, very kind. You know, one thing that I think is true about this curriculum that may not make many people happy at first, but it seems to be making you guys is it really wasn't designed for your children. It was designed for the parent who has some sense and has some familiarity to really get good at it, so that over this generations, we can explain it to our children and they can start to understand it too.
Yeah.
Well,
Whoever,
interestingly enough, I was doing fractions with my 11-year-old today, and he understood how to do it way, like he sees the patterns much faster than I do. And I'm just like, okay, hold your horses, because I've got to figure this out. You know, where he's with the notation cards, he's like, oh, I know that's a subset. And he goes to the charts and he's looking at the charts and he's, you know, we're reading through it and he's figuring things out way faster than I am. So.
Good.
yeah, whoever shared last week that video for the classical mom on the bases. So I just felt like I couldn't move on. My daughter's in challenge B. So we have, you know, we're not doing this in community, which sort of is not as fun, honestly. But I was like, I can't move on. And she had a student in class present on it. So she just was like kind of baffled. But anyway, that video helped me get it. It was so great. And I could spend the time and then I could explain it to her. And we just had so much fun. That was, I think, that math was fun. And then when we were looking at the very first 2 pages, like we do every week, we're looking at relations. What I was thinking about is each week, and she and I are only on week 3 together, is I'm beginning to see the relations of all the pieces of the math map. And like, so now I'm not freaked out, like, oh my gosh, we are not even doing math. And how is, you know, 5 years down the road, how is she going to go to college? Like all those things that we whip ourselves up about, you know, is like, no, like now we're excited for exponentiation in a couple weeks because we've been doing the flashcards. And so all the pieces do overlap. But I don't think for parents who are freaking out, and I see them freaking out, is like, well, you can't just do the math map and call math done. Like all the pieces are related and it's awesome.
It really is a beautiful thing. I was going to say, I have no children in Challenge A, but we are doing the math map at home with Essential Student and Challenge B and Challenge 2. And we don't always, or they don't always complete their 16 worksheets. So I've just sat down and started completing them just today because, you know, I think it's good practice for myself. So I'm glad to hear, Lee, I'm glad to hear you say that it's for the parent. And I absolutely feel like it is equipping me to be able to teach my children later on.
Yeah, I appreciate all that. You know, when my Robert was born, one of the first things I did was hired somebody with some girlfriends to teach us phonics so that we could teach our children phonics one day. That it really is about our education and our service to the Lord, and our children are just our first mission. And we kind of get it backwards in education. So I just really value all of you.
Can I share an embarrassing moment of learning?
Yes.
So I remember, okay, we were looking at unit conversions today, and I just wanted to share this. Maybe somebody else was as stumped on that as me when I realized just that you can flip them just so that you can cancel the different units. That was like a mind-blowing moment for me, and it helped me so much. I remember being a Challenge 1 director and being like, I don't get it. And my kids would be like, you just do this, Miss Tanya. And I wouldn't understand what they were saying. And then finally one day, probably it was one of my children that told me, you can flip it, Mom, so you can cancel. And I was like, wow, it was cool. Anyway, and I love the green box for the one because it all kind of goes together and helps like expand your brain and go, oh, these are all similar.
Good job. Now you'll be able to study physics, because that is the #1 barrier to physics, is your units and understanding how they cancel and flip around each other.
That's true. I did Challenge for the last 2 years directing, and you're right. It absolutely saved my life.
I appreciate all of your testimonies. That's been so encouraging to hear, and I'm sure it's encouraging for everybody else. So I'm going to ask this on Babs' behalf because Babs has been our collector of testimonies. If you do not want her to listen to this video and write down your testimony that you shared, please let her know. Don't use my words. But if you don't mind her copying your words and perhaps sharing those elsewhere, then don't do anything. So we're going to ask you to opt out. Otherwise, we're going to use your words because that is encouraging to other families to hear. And Tanya, just what you said, right? Like, there's nothing to be ashamed of when we go, I didn't get that, right? Even if everybody else in the room did, you had a moment of real understanding and learning. And that should be something to be celebrated. And we want our kids to know that it's okay to not get something and to persevere until we do. So
we're hoping to build a community of people to argue about math with. Right, and then that implies that neither side quite knows what they're doing, but they're curious enough to wrestle with it till they find out. And that's what will make it so that over time, more and more of us not only love mathematics and see God in it, but have that strength and ability when somebody secular or STEM or whatever comes up against us with an argument, we'll be able to go, wait a minute, I've struggled with this stuff before. Give me a minute and I'll answer you.
Oh, Kim, I don't know if we have an update on when more flashcards are coming in. Oh, there we go. Shauna got that. All right. Well, if there are no other questions, we have hit our 2 o'clock. We actually finished on time, but does somebody else, was that another question coming in?
Yeah, Kirsty, I have a question on the week 5. I think also saw it on the week 6 too. So the division part is shown as a fraction way. Let me see, it's on week 5, page I3. In the middle section, it said 12 divided by 2. Why the equal sign is tilted? Is it
so that's Lee's way. I think it's a very nice compact way of just showing that prime factorization. So I think this is what your question is. So if I say 12 and we're dividing by 2, right? If we're looking for our prime factorization, we divide by our prime factors in order. So 12 divided by 2 equals 6. And so that's just showing that relationship there. Then I can divide 6 by 2, and that would equal 3. 3 is not divisible by 2, but it is by 3. And that would give me my 1, and I can stop. And so here's my prime factorization for 12. Is that your question?
Yes, I understood that the prime number, but I was just curious why the equal sign was tilted.
Yeah, just to help students see that pattern.
Okay. And I do want to share one thing. English is not my first language, and then I'm teaching my children in the English. And when I saw all the mathematic different curriculum, there was so many problem solvings, and it was very overwhelming for me to teach sometimes. But when I look at the math map, I was so excited because the patterns and the comparison between the log and the root. When we did this with our challenge A and challenge 2 student, and my challenge 2 student was so excited, even though she was doing the Shulman math and Saxon, she looked at that, oh, I got this. And then she wanted to bring that to her challenge 2 class, and then to show her student, her peers. And she came back, said, Mommy, I made it. And nobody really, I don't think anybody understood it, but I'm fine. I understood. So I was so proud of it.
It's great.
Well, your English is excellent, and it puts us all to shame because I know we as Americans, we're also English first. And it seems like everybody in every country around the world but us has at least 2 or 3 languages they speak. So
yeah,
I appreciate that. Thank you. And also, I was communicating with one of my parents who just started Challenge A, never did CC before, and was so nervous. And when we shared this, when I shared the math map, she was on board so quickly, but she was very overwhelmed. we were talking every other days and about the layout of a math map. And yesterday, during our community day, her child was sharing with her her classmate. I overheard. She said, "Do you know we are learning some of the stuff even we learned from college, and we learned something is the concept from the college level." And she was so proud of. So I asked her, "That means do you need to know everything? Do you need to understand everything?" She said, "No, but eventually I will." So that was a very aha moment.
Good.
That's beautiful. Thank you for sharing. All right, well, thank you everybody for being here today. And I'm excited next week. We're going to talk about exponentiation. And that was personally like one of my biggest mathematical aha moments. And in a place where God really met me to teach me about math as we were writing this curriculum. So I'm excited to share that with you next week. And I will look forward to seeing you guys then.
Bye.